Hello everyone, welcome to this video. So in today's session, we want to look at how to find the standard deviation. This is mathematics, by the way. The topic, statistics. So let's read and answer the question together. So the question reads, the ages of people living at Pamodzi village are recorded in the frequency table below. So this is the frequency table, and our task is to find the standard deviation. So find the standard deviation, and this carries 6 marks. So this question comes every year in mathematics paper 2. So it's something you don't want to miss out on. So before we can answer this question, let's first of all go through the basics. Then we come back and answer it together. Okay, so usually when we give data set, when we give out data, data can either be ungrouped or grouped. So this brings us to two types of data grouping. We have grouped data or ungrouped data. So we have ungrouped data and grouped data. Now, what is grouped data? What are the differences? So let's just quickly go through this. So when data is ungrouped, what we mean here is data set is given individually. It's recorded in the exact form the way it was collected. So if you collect data, then you don't put it in any organized form. You don't put it in class intervals. Then we say the data is ungrouped. So here we are saying data is given, it's recorded individually. So the data is recorded individually. It's not organized. It's not organized, but what I mean is it's not put in class intervals. So there are no class intervals here. There are no class intervals. So once you see something like this, where we have individual data set and it's not in any class, there are no class intervals, then we have ungrouped data. Otherwise, we have grouped data. So by grouped data, we mean there are class intervals here. So there are class intervals. Data is organized. Data is organized. So data is organized and we have frequencies. So data is classified. We have class intervals. It's organized with frequencies. Then we have grouped data. So one more thing, we have ungrouped data and grouped data. Ungrouped data, we have individual data set. There are no class intervals. There are no frequencies whatsoever. We have ungrouped data. How about grouped data? Once we see that data is organized, it's in ranges, it's in classes with frequencies, then we have grouped data. A good example, let me give examples of grouped and ungrouped data. So let's say we are talking about marks scored by students in a mathematics test. Let's say that for ungrouped data, the marks could be recorded like 40%, 50%, or 60%, 70%, 40%, 55%, and so on and so forth. So you can see that here we report data as individual data set. So once we have individual data set, then we are talking about ungrouped data. However, if we try to create ranges, let's say we have data set like this, 10 to 30, 40 to 50, 60 to 70. So you can see that this time around, we can even now put how many were in this range, maybe 2, 3, 1. So once we have class intervals, 10 to 30, we're not talking about individual data set here. We're talking about the entire range. We're talking about marks from 10 to 30, marks from 40 to 50. So you can see that here we now have class intervals. So once we have class intervals, then we're talking about grouped data. So the other thing that you see that is in grouped data, there will be frequencies. In ungrouped data, it's like each frequency is simply one, so there are no frequencies there. But in grouped data, we have frequencies. So now that we have a general view about what grouped data and ungrouped data is all about, let's go to these formulas. So these formulas are the tools that we'll be using to find the standard deviation. So let me just quickly explain. Don't be scared when you see these formulas. They are very simple and straightforward. We'll try and explain and make it easy for you to understand. So these are the formulas that we use now to find standard deviation. So these formulas, for the purpose of this video, are for grouped data. But I'll try and explain for grouped data as well. So before we find the standard deviation, we need to find something called the mean. So the mean, this is the symbol x with a bar there, so x bar. So mean is simply equal to the summation. This symbol means summation. This symbol means summation, means the sum. We're taking the sum. So the summation of fx divided by the summation of f. So to find the mean, this is the formula that we need to use. Mean is equal to summation of fx divided by summation of f. Then after we find the mean, we can now use it to find what we are calling the standard deviation. So here, SD simply means standard deviation. So standard deviation is equal to the square root of fx squared divided by summation of f minus mean squared. Then we take the square root. So do we need to memorize these formulas? Well, if you want to understand and make it easy for you to do the calculations, you need to know this formula. Otherwise, this formula is given to you on the first page of mathematics paper 2. This formula is provided. So what you just need to do is you just go there and see the formula. You find it there. But otherwise, you can also just try and memorize the formula, understand what's happening here. So one more thing, mean is equal to summation of fx divided by summation of f. So f is the frequency, the number of times a particular data set appears. That's frequency. X is the entry, the data entry we are talking about. Yeah, f is the frequency. So this is what we need to use to find standard deviation. Now, for us to completely find standard deviation, what we're going to be using is a table that looks something like this. So you need to create a table, first of all, that looks something like this. Then you fill it up. Once you fill it up, you're going to gain 3 marks. So when you gain 3 marks, you're going to use the information from there now and compute the standard deviation. So this is the table that I want you people to know. So for you to find all these, the mean and the standard deviation later on, you need to first of all come up with the table. So come up with this table, and this table is very easy to set up. So what we need to do is create something like this. But how do we create it? This is the format. So first of all, you're going to put the frequencies here. So F stands for frequency. Then later on, you put the data entry here, X. Then after that, you multiply. You can even see the way it's going there. So first of all, we have F, then we have X. Then the next is F times X, so we have Fx. Then after that is Fx squared. Fx squared simply means I'm now getting Fx, then I'm multiplying again by X. That's why we have X squared there. So once you have this table, you fill it up. You're going to find the sum here. So the last stage here, you find the sum of F. So in this case, here we're going to find the sum of F. So here we find the sum of F. This stage we find the summations. What are they summing up to? What are they summing up to? Here we find summation of Fx. Here we find the summation of Fx squared. Why are we doing all this? Remember, when we come back to the formula here, to find standard deviation, we have Fx squared, meaning we need this. Where are we going to get this? That's why we're coming up with this table to help us now find this Fx squared. So sum of Fx squared, what you're going to have here, once you find all the values here, put them together, add them, then you have fx squared. That's what we're going to have here. Then f is summation of frequency, total frequency. So the total frequency is simply what you're going to have here. So once you have all the frequencies for the data set, you add them up, you sum them, then you're going to have the sum of the frequencies, sum of f. Then sum of fx, once you find fx here, you simply need to add them up. You add the fx here, fx there, fx there, then you're going to have the total. Then with this filled up, you can easily compute the mean, you can easily compute standard deviation. So the first step, let's come up with this table. Once we come up with this table, then we come to the formulas. It will be very easy. So let's apply this data and see if we can find the standard deviation for the problem that we have today. Okay. So our task is to find the standard deviation here. So first of all, let's draw up the table. So before anything else, let's draw up the table. So solution. So we draw up the table. So we have f, remember? Apart from that, we have data entry x. Then we multiply f and x, we get fx. Then we multiply fx and x, we get fx squared. Now, where do we get all these fx, whatever? So f stands for frequency. So the number of times something appears, the data entry is appearing, that is frequency. So from the table, we can see number of people. So this is the age. So the age of people is given, that is the data that we are given. But the number of times that a particular set is appearing is what we have here, the frequency. So this is where we're getting the frequency. So we just get the frequencies here. We put them there. So we have 7, 22, 22, we have 28, we have 23, we have 15, so you can use a ruler to come up with straight lines, and we have 5 here. Okay, then x is the data entry, the midpoint now. So because they were given in class intervals, they were not given like in direct form. We need to find x. You can see that x is in between two bounds, the lower and the upper. So x is the midpoint of the data set that we have. So let's find x first of all. To find x, we add the lower plus we add the lower to the upper bound, then we divide by 2. We find the midpoint of each class. So here we get 0, we add it to 10, then we divide by 2. So 0 plus 10 is 10, divide by 2, we get 5. So x here is 5. Then here 10, we add it to 20, we get 30, divide by 2, 15. We continue doing the same procedure. So here we have 20 plus 30, that's 50, then we divide by 2, 25. 30 plus 40, that's 70, then we divide by 2, 35. This will give us 45, and this will give us 55. You can check through. Okay, so that is x. So sometimes these are already given. Once these are given, we don't need to find the midpoint. No, we just get them like that. But in this case, once we have the data set in a range 4, we need to find the midpoint. Then that is the value of x. So the value of x is what we're going to put here. So we have 5 here, 15, 25, 35, 45, and 55. Then after that, we need to find fx. Let me just grab my calculator. Okay, so we now need to use our calculator. This is mathematics paper 2. Calculators are allowed. So we need to find fx. We start multiplying. You can see fx here means you get f and x you multiply. So 7 times 5, 35. We can even finish up throughout like that. So you can say 7 times 5, 35. So that is fx. Then fx squared simply means you are getting this fx, then you multiply by x again. So fx squared means fx times another x. So once you get your fx, which is this, then you multiply by x again. So what it means here is 35 times 5. So we get 175 here. Then we go to this one, fx, it means 22 times 15, 22 times 15, 330. Then multiplied by x again, so we multiply by 15. So we're getting 4950. You can check through. So here 28 times 25, we have 700. Then times 25 again, we have 11, 7500. Okay, let me just write that again. So this should be 17,500. So 23 times 35, we have 805. Then times 35 times x again, 28,175. Then 15 times 45, we have 675. Then times x again, we have 30,375. Then 5 times 55, we have 275. Then times 55, we have 15,125. Okay, so we are done filling up the fx squared. The last stage is to find the totals. Remember, when we go back to the formula, we need to find the sum, the summation now. Okay, so let's now find the totals. It means we need to find the total frequency here. So the total frequency, so we are finding the totals in this. Okay, so in the last row, we need to find the totals. So we add. When we add here, so we have 7 plus 22 plus 28 plus 23 plus 15 plus 5. Okay, so the total frequency here is 100. So we had 100 people here. Then we add we don't need to add the x's because it doesn't even appear in the formula. We are only interested in the summation of f, summation of fx, and summation of fx squared. So let's add fx. So 35 plus 330 plus 700 plus 805 plus 675 plus 275. So I'm getting 2,820. So 2,820. So let's add now this. So 175 plus 4,950 plus 17,500 plus 28,175 plus 83,75 plus 15,125. Okay, so for this, I'm getting 96,300. So make sure you are pressing the right values there as you use your calculator. So after that, what remains is to use the formulas. Remember, we now go back to the formulas. So remember, standard deviation is summation of fx squared divided by f minus mean squared. So do we have summation of fx squared? Yes, the total fx squared is this value. Do we have summation of f? Yes, we have the total frequencies there. So we have total frequency here. We have total fx squared here. Now, what's missing for us to compute this is this one, the mean. So let's first of all find the mean. So mean, we said, is summation of fx divided by F. So once we find the mean, then we're going to plug it in there. When we plug it in there, it will be very easy for us to find the standard deviation. So summation, mean will be equal to, so fx, so the fx is 2,820 divided by 100. So when we divide, we can clearly see that the mean here is 28.2. So this is the mean. So by finding the mean, we now get the mean and put it there. So we can now conclude here and say our standard deviation SD is equal to, so fx squared we know is 96,300 divided by mean, summation of f, which is 100, then minus, this should be, everything should be under the square root. So mean is 28.2 squared. Okay, so at this stage, you can simply use your calculator and write down the answer there. So 96,300 divided by 100. So if you want, you can first of all work with this, then you subtract there. Or you can first of all say, or you can just go and do it at a go. So 96,300 divided by 100, I'm getting 963. Then minus, so don't erase anything there, just say minus, then you put the brackets, 28.2, then you square it. So what I'm getting now is this. So 167.76. Then we now need to find the square root there. So you use your calculator here and say standard deviation. So you don't erase, you just press square root there and say answer. So it's giving me 12.95. Okay, so this is the standard deviation that I'm getting. But usually the examiner asks you to say, if the answer is not exact, you should leave it correct to 3 significant figures. This could still be correct, but if you want to leave it correct to 3 significant figures, you can count and say 1, 2, 3. But after 9, what do we have there? 5. So we can say we get a 1 there and add it to 9. So it becomes 10. But we don't write 10, we get this one and give it to the next number, it becomes 13. So we can conclude and say standard deviation SD is equal to 13.0. Otherwise, even a student that writes something like this, they will still give them marks. So this is the standard deviation, and that's how you do it. Okay, so that is all for this video. And if you're joining us for the first time, please remember to like our page. You can invite your friends and leave a comment there. Until next time, it's bye for now.